Hi there, my name is June McCallum and I've been working as a volunteer research assistant. I'm also a second-year undergraduate at the University of Glasgow. The software I used in this project was Cesium JavaScript because it is accessible, open access and easy to use. So for this project I developed a tool on Cesium JavaScript that would allow the comparison of transport methods to and from Glasgow. So my project looked at driving, cycling, walking and then multimodal transport methods such as park and ride, walk and ride and cycle and ride. The motivation for this project was the fact that in Scotland the highest polluting sector is domestic transport, and often people choose the most convenient option to get from A to B. So for this project I looked at 4 areas that people may commute to Glasgow from and analysed the transport methods that you could take from there to get to Glasgow. I looked at the route time, the distance and the carbon emissions from that. So additionally for this project I included the ability to let the user manually choose the start of the route. This allowed the user to manually assess the metrics associated with the route they chose, such as the route time, the distance and the carbon emissions resulting from the methods of transport. To achieve this, rail data was taken from the OpenStreetMap online OS map using the API Overpass Turbo. The rest of the non-rail data was taken from the Open Route Service API. Using Bentley Systems' Cesium tool made it very easy to render and visualise the metrics we were looking for. This included visualising the route as a polygon and using the height of that polygon to represent the carbon emissions related to that mode of transport. The Department for Transport in the UK identified that there are 12 personas that use transport in the UK, and for future work we would hope to integrate this further into the model to achieve a better reflection of the population. This would help to encourage a shift from using private vehicles to public transport. I felt like I met my aim for this. The model could be improved, but it definitely does do, at an approximate level, what I was trying to get it to do. It evaluates multimodal transport towards Glasgow, providing CO2 data, the time data and the distance data. It allows you to compare, or it allows you to kind of evaluate how connected a place is. And so I think if I was to expand it in the future, I would definitely add in more kind of persona-focused stuff, data sort of focusing on, right, if I could get more data as to who's living where, we could find out what kind of decisions people would need to, or the government would need to make to encourage cleaner travel from that area. Over the 12-week sprint, this experience has been very useful as it allowed me to see a project coming together and learn how research is conducted in academia.
My name is Alexander and I am volunteering research assistant at University of Glasgow. The challenge of my project addressed that number of electric vehicles is growing significantly faster than charging infrastructure. And what we need to do is make sure that charging infrastructure match this increase. For example, electric vehicles number from 2023 to 2024 increased roughly by 40% just in 1 year. However, charging growth increase in much slower rates, typically around 15–25% per year. It means that demand is rising significantly faster than supply. At the same time, only 34% of homes in Glasgow have off-street parking, meaning that most people depend on charging infrastructure. Survey data also shows that a main barrier for electric vehicle adoption is lack of infrastructure. So charging points are not optional, they're essential. For this project, I utilized Glasgow city region as a test bed. And for this project, I used Bentley Systems Cesium, Microsoft Azure and Charging Place Scotland. While charging point Scotland provide real-time availability, this system extended by capturing and analyzing usage over time. Data is collected from charging point Scotland using Azure function that runs every 5 minutes. For visualize this data, I use markers, extrusions, and boundary for visualize specific place. The user interface included toggles, buttons, and also structure with boundary sensors and electrovehicles prediction. Within dashboards, it was easier to deploy 3D structure of charging points in car parks. For example, this one of busiest charging points, and these charging points was monitored approximately 165 times per day, over for now already 24 days, resulting in 3,000, almost 4,000 observations, with even average utilization or average busiest time 45%. These charging points was occupied roughly by 1,700 times. And this approach can be scaled beyond Glasgow to smart infrastructure planning in, for example, United Kingdom.
My name's Dr. Daniel Mitchell. I'm a research associate at the University of Glasgow, and I've been supervising Ewan and Alexander during their 12-week projects. Ewan and Alexander came to us initially following a Bentley Systems iTwin for Good project, which they took part in, where they utilised an ultrasonic sensor, some cheap electronics, and connected it to the Bentley Systems iTwin system that they'd created. Within our Introduction to Programming 2 course at the University of Glasgow, I showed a demonstration using the Cesium JavaScript tool, which inspired Ewan and Alexander to ask, can we do a follow-up project following the iTwin for Good project which they took part of? So one of the things that is absolutely tremendous in this project is that Ewan and Alexander are only second-year undergraduates, and they have really got into grips super fast with the Cesium software. They have been programming using JavaScript and also Python to be able to figure out how to address some quite complex problems, which even as a postdoc working within the transit project doing digital twinning for transport decarbonisation has been a quite difficult research task. So it's brilliant to see the progress that they've made.